Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration of improper integrals. This is part 8, and I encourage you to check out the videos prior to this. Subscribe so that you don't miss out on our future uploads. Today's business. Improper integrals. These are definite integrals which become infinite when f of x is evaluated at any point a or b, that is to say in the interval from a to b inclusive. There are 3 improper integrals. Let's look at the first type. So for type 1, we are saying that the definite integrals with one or both infinite limits. So, if we have integral from a to b of f of x dx, whether a or b or both is plus or minus infinite, then we are going to have an improper integral of type 1. So, what is the approach that we have to apply for this type? First thing we do is to replace the infinite limit with a finite variable p and introduce the limit as p tends to the plus or minus infinity where the limit exists. Great. Let's have a look at an example. So the diagram shows part of the curve with equation y is equals to 10 over 2x plus 5 squared. So we have it over here and we have the shaded region. So as we can see, we see 2 asymptotes, one with the x-axis and the other one with the y-axis. So we are asked to show that as p tends to infinity, the shaded area tends to 1. So the solution, we would need to substitute for the infinity. So because we see that p can go on and on. So instead of having infinity for the upper limit, we are going to replace that with a p. So we are evaluating from 0 to a p. Great. So now when we integrate, remember from our part 4 video and part 3 of integration, we spoke about integrating such type of expressions. So by using the laws of indices, we are going to have the integral from 0 to p of 10 times 2x plus 5 to the power minus 2 dx. As we do so, we are going to have minus 10 times 1 over 2 times 2x plus 5 to the power minus 1, and simplifying that, which we have in the square parenthesis, we would have minus 5 over 2x plus 5, and we evaluate from 0 to p. So if we do so, we are going to have 2 terms, and those would simplify to minus 5 over 2p plus 5 plus 1. From there, we take limits as p approaches infinity. So if we do so, we can see that the 1, because it doesn't have any p variable, it will be the same. If we take a limit of any constant, it remains that same constant. However, when it comes to the first part that had the denominator of 2p plus 5, in this case, we would have that one approaching 0. So as that approaches 0, it means that we can actually confirm that the integral from 0 to infinity of 10 divided by 2x plus 5 squared dx approaches 1. So we have managed to prove that, or to show that, to be more precise. Great. We move on to type 2. For the definite integral, that is the integral from a to b of f of x dx, then if we have f of a or f of b, and or both is or are undefined, then in such a case, we say this is a type 2. And take note, a and b may not necessarily be infinite or infinity. Great. So now let's look at the approach suitable for such type of improper integrals. The first thing we do, as before, we replace the undefined limit by replacing it with the p and introduce limit as x approaches that particular limit where the limit exists. So we are not saying that the limit itself is undefined, but substituting with that limit would result in the f of x being undefined. Let's take a look at an example. Evaluate the integral from 4 to 8 of 4 divided by the square root of x minus 4 dx. So the solution, we need to try out the two limits. So as we substitute for x with 4, the lower limit, we can see that we have a 0 in the denominator. And we cannot have a case where we divide by a 0. Otherwise, f of x becomes undefined. So in this case, we have an improper integral of type 2. Then we use the approach that we have highlighted or outlined before. We replace 4 by a p so that we have integral from p to 8 of 4 divided by square root of x minus 4 dx. We take the integral, but remember from the laws of indices, we can have it as the integral from p to 8 of 4 times x minus 4 to the power minus half dx. And that would give us 8 times x minus 4 to the power half from p to 8. Now we substitute with the limits and subtract. This is what we would get. 16 minus 8 times p minus 4 to the power half. Now we take the limits as p approaches 4. So limit as p approaches 4, we are going to have 16. Recall 16 is a constant, and if we try to find the limit of a constant, we'd always get that constant. We focus on the terms, the p terms, which are in the other part. So as we substitute there with p approaches 4, limit as p approaches 4 into 8 times p minus 4 to the power half, that would become 0, because when we substitute with the 4 there, that goes to 0. So that approaches 0. As that approaches 0, it then means that integral from 4 to 8 of 4 divided by the square root of x minus 4 dx approaches 16. That is our final answer. Let's move on to type 3. So for the definite integral from a to b of f of x dx, where we are saying we have another variable c that is in between a and b, f of c is undefined or invalid. So the approach, we replace that particular c we have identified that lies in between a and b by a p, and then separate the integral to the form a to p f of x dx plus p to b f of x dx. Then take limits from the negative on the first integral and from the positive on the second integral. So that is what we would have. Limit as p approaches c from the negative of f of c, but this is a capital letter F, and limit as p approaches c from the positive of capital letter F of c. Let's look at an example. Evaluate the integral from minus 1 to positive 1 of 1 over x squared dx. So for the solution, so we note f of x is defined for both limits minus 1 and 1. However, at 0, which lies in between the minus 1 and the 1, f of x is not defined because we cannot divide with the 0. So c is equal to 0 in this case. So in that case, we have an improper integral of type 3. So now how do we go about this? We replace c by p so that we get the integral from -1 to p of x to the power -2 dx plus the integral from p to +1 of x to the power -2 dx. In so doing, we are going to get a minus x to the power -1 with the limit from -1 to p plus the same with the limits from p to +1. Now, let's consider the first square parenthesis part, because if it diverges, then there won't be any need for us to cross over to the second part. We can conclude from there that there is no solution. Now, so considering the first part, we substitute with the limits from -1 to p, then we get that which is 1 minus 1 over p. Then we move on to take the limits as p approaches 0 for 1 over p, because we know that if we take the limit of a constant, we'll always get a constant. So that 1 remains there, but the 1 over p might change. So now with this, and we're taking limit as p approaches 0 from the negative of 1 over p, we see something here. We see that this diverges, or it becomes undefined. As that becomes undefined, therefore, there is no solution for this particular problem, and we conclude the solution does not exist. And also, there won't be any need for us to cross over to the second part, because once the first part is undefined, then the whole thing becomes undefined. Or if the second part is undefined, then every other thing becomes undefined. So, if you've made it this far, congratulations. I leave you with the following task: the integral from 0 to 25 of the square root of x plus 1 over x squared dx. Thank you so much for watching Numbers Simplified. Make sure to like, share, and subscribe so that you don't miss out on any of our videos. God loves you.